It's Mrs. Weethy back for Unit 1 Video Lesson 10. Just think, only 7 more to go. And this one is on calculating specific heat, which actually we already did in the Bunsen burner lab. So to calculate the specific heat is the letter C of a substance. You're going to divide the heat input by the mass of the substance times the temperature change. Okay, so your equation, C is equal to Q, which is the heat, divided by the mass times the change in temperature. Heat has a unit, joule or calorie. Mass is grams, and change in temperature will be degrees Celsius. Now take a look at this equation right here. Does this look familiar? Q is equal to mc delta T. That's right. We used this equation in the Bunsen burner lab. It's the same thing, except now we have solved this equation for C, for the specific heat. We can do the same for mass, and we have actually used it for the delta T. Alright, so let's take a look at how we're going to use this. So as I said, Q is the heat, expressed in terms of joules or calories. M is the mass. Delta T is the change in temperature, where the change in temperature is always the final temperature minus the initial temperature. The units for the specific heat are either joules over grams degree Celsius or calories over gram degree Celsius. It just depends on what your unit is for Q, for the heat. Alright, so let's take a look at this. We're going to look at a sample problem, and then you're going to practice these kinds of problems in your practice packet. The temperature of a 95.4 gram piece of copper increases from 25.0 degrees Celsius, that's your initial temperature, to 48.0 degrees Celsius when the copper absorbs 849 joules of heat. What is the specific heat of copper? Alright, so the first thing that we have to do, and this is the way I want you to write it down into your chill and when you're doing any kind of problems. First you have to analyze, list the knowns and the unknown. Alright, so your knowns, you have the mass of copper. Now this is the way we usually do notations here. So mass and then subscript, put the symbol for the element copper is equal to 95.4 grams. The change in temperature, and let's calculate that. Final temperature was 48 degrees Celsius minus, there seems to be a bit of an error there. Okay, so if we kind of go back to the problem, the initial temperature was 25 degrees Celsius, so we want to actually change this to 25 degrees Celsius, and that gives us 23 degrees Celsius as our change in temperature. Q is 849 joules. The unknown then is the specific heat, and the units for the specific heat will be joule over gram degree Celsius, since joule is our unit for heat. Alright, so let's calculate, solve for the unknown. You're going to start with the equation, and anytime you do problem solving, that's what I want you to do, is I want you to write the equation. So our equation is the specific heat of copper is equal to Q over the mass of copper times the change in temperature. Now we're ready to put the numbers in. So substitute in the numbers. Q is 849 joules over the mass, 95.4 grams, times 23.0 degrees Celsius. And when we do our math and the calculation, we get 0.387 joules over gram degree Celsius. Okay, so that is a specific heat problem. Now, keep in mind that with these kinds of problems, you can solve for specific heat, you can solve for heat, for mass, for the change in temperature, any one of those variables, and you will be practicing this. This is Mrs. Weethy. We're done with this video lesson for now.